What will the Earth's climate be like in the future? Climatologist Warren Washington at the National Center for Atmospheric Research is using mathematical and computer models to find out.
We have discovered that the amounts of carbon dioxide and other greenhouse gases such as methane have been increasing.
He explained that one function of the atmosphere is keeping the Earth warm. These greenhouse gases allow sunlight to pass through to the Earth's surface, but trap some of the radiation that would otherwise escape out into space. Over the past 1,000 years, this blanketing effect, called the greenhouse effect, has kept our planet about 33 degrees centigrade warmer than it would otherwise be. The scientists at NCAR decided to study how an increase in one greenhouse gas, carbon dioxide, might affect the entire climate.
The present rate of increase of carbon dioxide is roughly 0.5% per year.
Shown on a graph, the changes in the Earth's carbon dioxide concentrations look like this.
In order to make some sense out of that graph, we generate a best fit plot, and that plot essentially shows the trend from the 1971 until the present of the Mauna Loa carbon dioxide concentration. And we measure this carbon dioxide not only at Mauna Loa but other stations around the world, and it is increasing dramatically. We expect that by the year 2030 or 2040 or so, into the next century, that we will have a doubling of the concentration of carbon dioxide. There's been a great deal of controversy about this in the media and so forth, and that is because we haven't seen very much warming over the last 20 or 30 years. We've seen roughly a 0.5 degree centigrade, which is roughly a 1 degree Fahrenheit temperature change. However, that sort of change is actually going to cause major changes in the climate if it continues.
To see how increasing carbon dioxide could affect the climate, Dr. Washington and his co-workers used data from around the globe and supercomputers to make a model of what Earth's climate could be like if carbon dioxide levels double.
For the model, we have a three-dimensional grid structure in the oceans, in the atmosphere, and in sea ice. And it roughly represents something of the order of 10,000 points around the entire globe in the atmosphere and in the oceans. These are the points where we actually calculate in the computer all of the various variables that go into making a forecast. For example, temperature, moisture, the salinity in the oceans, the prediction of the winds and the currents and so forth.
The supercomputers process billions of measurements to make a map of the Earth, showing how temperatures could change during each month over a period of years.
It's hard to estimate exactly how all of the changes in the climate system could affect our lives. One of the things that we're expecting is that we will have warmer temperatures. The largest amount of warming is in the higher latitudes, and that is due to the fact that the ice caps and the sea ice melts back a bit. Now, what this will probably lead to, if our models are correct, is in the wintertime a much warmer wintertime temperatures. In the summertime, it could lead to several things. One is that we'll see in the summer drier soils, which could affect crops. Maybe we'll have more hurricanes. Maybe we will have stronger hurricanes. And that would be consistent with having warmer temperatures over the oceans. We're making an estimate of what the climate will be in the years 2030 to 2050. We're seeing warmings up to 5 degrees centigrade in these regions and roughly 2 or 3 degrees centigrade over the tropical regions.
Fitting functions to data, whether as a line graph or as a computer model, can help us predict future trends with increasing accuracy.
This is positive proof that global warming does exist.